Good day, everyone. I welcome you all to this exciting training on sonography made easy for radiography students coming your way via BMedics. BMedics simply represents Bright Medical Imaging Solutions, and our intention is to educate the younger generation to understand the basic principles and how ultrasound basically works. So welcome once again. And in this training, we'll be looking at types of ultrasound machines. Types of ultrasound machines. Ultrasound machines vary by form factors, capability, portability, power sources, etc. Now we'll be looking at the type, description, key features, and advantages of the different ultrasound machines we have. First of all, we have the ones we call the CAT-based trolley ultrasound consoles. We have the portable mobile ultrasound systems. We have the laptop, and we have the handheld ultrasound devices, including phone and table connected. So let's look at the various description for each. For the trolley base, which you will still see the diagram, we have large machines mounted on wheels, usually with full console, many knobs, multiple probe ports, large screens built for hospital imaging departments. The advantages with this type of ultrasound machine is that very high image quality. It comes with very high image quality. It has the option of multiple modes ranging from D mode, B mode, M mode, Doppler modes, Doppler power modes, and all of that. So it comes with varieties of modes that you can use. Then multiple probes. It comes with multiple probes connector. You can have as much as 4 probes connected at once, and stable power source. You know, good for heavy and varied use. For instance, obstetrics, cardiology, radiology, and all of that. Then for the portable or the mobile ultrasound, smaller than a trolley machine, but more capable than simple handheld. Could be laptop style, table style, or small suitcase system. Some are battery powered, moved between rooms and wards. Good compromise. The advantages include good compromise, decent image quality, flexibility, can be used at bedside, in emergency rooms, ICU, and easy to be transported. Then we have the next one, which is the laptop ultrasound machine. This is a system built into or attached to a laptop or small computer unit. Now, let me expatiate on this to help you understand the difference between the portable and the laptop. We have two types of laptop system. One is the one that is compatible with a normal laptop, where the program is installed in a normal laptop, and you can use an external component connected to that laptop and you do your scans. The other is a portable laptop configured ultrasound machine, where everything is inside the machine. So you can have these two types under this category. So here we see a system built into or attached to a laptop or small computing unit. Sometimes probe connects via USB or part of a dedicated laptop machine with control units plus probe, often used in more mobile setups. The advantages with this is very portable, relatively lightweight, good for remote clinics, field uses, easier to transport, can share computing resources. Then the last one is the handheld, which is of more modern generation. This handheld device, they are very small transducer probe. It comes with small transducer probe plus minimal control unit, or using external device, for instance, phone and tablet. These are the ones you can actually connect to phones and tablets and use directly. Some devices are pocket size, connect wirelessly or via cable. Advantages with this include extremely portable, good for point of care, emergency setting, quick, rapid assessment, cheaper, but can be carried in bag, can even be carried in your pocket, useful for screening and fast decision making. These are ultrasound machines you use mainly for critical emergency cases that the location can be challenging. For instance, in the ICU, at site of injury and things like that. So basically, these are the different types. Now let's go ahead to see the different types based on their diagram. So this is the first one we talked about, the trolley base. It has a wheel and it has a very reliable component, that can withstand a lot of power challenges. That's why one of the advantages is power management. Then it comes with its control panel that has a very due to the largeness of the control panel, it has different functions, multiple functions. And another advantage it has is that it can come with multiple probe connectors. As you can see here, multiple probe connectors are connected here. Then we also have different probes. As you can see, this is the curvilinear probe, this is the linear probe, this is the cardiac probe, and this is the transvaginal probe. And another advantage it has, it comes with large monitor size, for good visualization of your images. Also, it comes with a slave monitor, which can be finger screen touch, to enable you with various options that may not be seen on the control panel. So this has a very wide range of advantages. The only challenge is it's not as mobile as the others. It can only be stationed in one place and mainly used for hospital purpose, major hospital cases. Then we have the second one, which we'll call the mobile unit. It's a very portable mobile unit, that can be carried around and comes with everything all in one. One of the advantages this has, it comes with its own battery power. So it can be used without being connected to the main power source, unlike this trolley type. However, the last trolley type I used personally, Sonostar, came with a battery pack that can last for some time, like 30 minutes, 1 hour, before you can now connect to your power source in cases of power outage. So but this comes with a complete dedicated power unit. Then we also have the ones we call the laptop. Here you have a tablet. Here is being used with a tablet. You can see the ultrasound probe can either be connected through a wire connection or through wireless to either your laptop or iPad or even phone, and you can actually scan with it. The last scan I did in a hospital where I used this probe alone with the app is around 7 million. We got it very expensive, but very, very, available whenever you want to use it. So it's a wonderful device. Then this is the handheld, which very, very portable for emergency cases. Then there are other patterns. I just use these images to give us an idea of these different machines. So we now go next to components of an ultrasound machine and how they work together. First and foremost, we have the transducer. The transducer is the probe. This is the key piece placed on the patient with gel. It both emits ultrasound sound pulse, and receive echoes. Inside the transducer are piezoelectric elements stroke crystals. When voltage is applied, they vibrate and generate sound. When sound returns and hits them, they generate voltage. Now, different probe type. We have the linear probe, the curvilinear probe or the convex. We have the phased array, or what we call the cardiac probe, and we have the endocavitary probe. We also have the what we call endorectal, the rectal probe. They have the same category. Now, each has different frequency, footprint, depth, and resolution trade-off. Take note of these various factors that differentiate the different probes, as we will get to see. Then the next thing is the pulse generator stroke beam former. This sends electrical pulse to the transducer to generate the ultrasound pulses. In more advanced system, the beam former shape the pulse, focus, direction, timing across elements in array probes, steering the probes, setting focal zones, etc. Now we also have the receiver stroke amplifier. After the sound wave bounce off internal structures and return, they are picked up by the transducer crystals, converted into electrical signals. These are generally very small or very weak, so they must be amplified and processed. So after amplification, we have the next device or component, which is the analog to digital converter, the ADC. The return signal are analog. To do digital processing, they are converted into digital signal via ADC. So the returning signal usually comes as analog signal, which the ADC converts into a digital signal. Then we now have the signal processor and image processor. Lots of signal processing happens, filtering to remove noise, envelope direction, echo time measurement, compensation for attenuation, dynamic range adjustment, beam forming, especially for array probes. Then image processor construct image from echo data, interpolation, scan conversion, turning data into radial or sector geometry, into displayable matrix and Cartesian coordinates, ranging, grayscale, color, etc. Now we have the next device, which is the display or monitor. Screen to show the image, sometimes with color, Doppler overlays, measurement. Also user interface like the button, knobs, touch screen, trackball, etc. that lets operator adjust gain, depth, focus, mode, B mode, M mode, Doppler, measurement, and image saving. So these are the components of an ultrasound machine. Then we also have the control panel and user interface, which we just looked at. Here is the where you have all the knobs, to control, select your modes, select your depth, depth setting, gain, focus, zoom, freeze, and all those adjustments you need to have a wonderful image. Then we have the power supply stroke battery. Like I said, most machine can just be connected to the power source. Some come with battery, package that will help retain power in the case of a power outage. We also have the data storage stroke connectivity. Here, storage of image, videos, ability to export, USB, network, DICOM, connectivity for telemedicine or remote reading, perhaps could storage, probes, firmware, fireware, and updates. So these are usually the online stuff. Then we have the auxiliary component, like the gel, to couple between probe and skin, avoiding air which reflect ultrasound badly. Probe capable or wireless link. Okay, probe cable or wireless link. Probe connectors, sometimes multiple probe ports, cooling, mechanical housing, wheels for trolley, ultrasound machine, then mounting arms, etc. So basically, these are the various components of the ultrasound machine we can look at now, ranging from the transducer or probe, the pulse generator or beam former, the receiver amplifier, the analog to digital converter, the signal processor or image processor, the display monitor, the control panel, user interface, power supply stroke battery, data storage stroke connectivity, and other auxiliary components. So let's now move on to how these components work together to generate an image workflow. The first is operator setup. For the operator setup, select the probe appropriate for application. Then turn on machine, choose setting like B mode, the various mode, depth, focus and all of that. Apply coupling gel to the skin to ensure good transmission. Then the next is the pulse emission. The pulse generator sends an electrical signal to the transducer piezo crystals. This produces a short burst of ultrasound wave. In array probes, different elements might fire in a timed sequence. Then we have the travel through tissue. Ultrasound wave travel through tissue. Some of it is reflected at boundaries between the tissue with different acoustic impedance, some transmitted further. We have echo reception. Echo return to the transducer, piezoelectric element receive them, convert back to electrical signal. Then we have the signal conditioning stroke amplification. Signals are amplified, noise reduced, perhaps time gain compensation to adjust for attenuation deeper in tissues. Then we have the analog to digital conversion. Analog signal becomes digital. Beam forming and image reception. Scan conversion, where they convert raw data which may come in fan or sector geometry or order to standard display for the monitor. Then we have the display or the real-time update. The processed image is displayed in real time. Operator can adjust setting on the fly, that is gain, depth, focus, dynamic range. Then we have mode switching or Doppler. Here, if assessing blood flow, Doppler modes may be used for instance, color or spectral that requires additional processing, measuring frequency shift. Then we have measurement and documentation. Freeze frame, measure distance, area, save image, videos, possibly annotate, store and transmit. Okay, so this is just an image of an ultrasound machine to show you the different components. We may not bother on that. We will see it in other lecture. Comparison and consideration when choosing between types. Here are things to consider if you are to choose or evaluate ultrasound machines. The first thing is image quality stroke resolution. Before you go for any ultrasound machine, these are things you need to take into consideration. You look at the image quality or resolution. How small, deep are the structures you must see? For instance, if you are working in a place where you meet variable cases, then you may need and you come across a lot of patients, you may need a trolley based machine which has those kind of variable options. Then the next thing is depth penetration versus resolution trade-off. Here we are talking of the depth such probe can penetrate, which has a lot to do with frequency. Higher frequency equals to better resolution. Less penetration and lower frequency gives more penetration but less details. So these are the trade-off you need to look at. Then portability. When you are faced with cases that will require mobility, moving from one place to the other, then you may have to go for the mobile unit, which is more ideal for that purpose. So in portability, will you move it often, bedside, field work, home visit? These are questions you need to answer. If your work may require all of these movements, then a mobile unit will be better off. Then battery operations, important for portable and handheld units. Then available modes. Do you need Doppler modes, color flow, elastography, 3D, 4D, volume imaging? If you need this, then you may have to go for the trolley-based ultrasound machine that gives all of these features. Then number and types of probe required. Some probes are expensive, different probes for different application. For instance, if you buy an ultrasound machine of 7 million that comes with 2 probes, to get extra 1 probe cost as much as 1 million. So when you are buying machine, you need to put into consideration the number of probes to get, because those probes are very, very expensive. Connectivity, image storage and compatibility. For instance, DICOM compatible, telemedicine, remote sharing. Now, modern ultrasound machine comes with these modern features where you can, after your scan, you can send your images via online to any location because of the current applications that are embedded in most of these new machines, which the older ones don't usually come with. Then the user interface and ergonomics, ease of use, trained personnel, speed of setup, cleanup, etc. There are some ultrasound machine that comes with very user-friendly interfaces where it makes your scan procedure very, very easy. Then we have cost and maintenance, purchase cost, probe cost, battery replacement, service and calibration. So you also need to, put all of this, into consideration when considering the machine you want to, purchase. There are some machines that are easy to maintain due to availability of parts and engineers.